In this video, we will work some example exercises similar to those you may see in the homework for 7E. In this problem, we will be looking at arrangements that are without repetition. So for this problem, how many license plates are possible if there are 3 letters and 3 single-digit numbers? And no repetitions. So in this problem, we cannot have a single letter such as A appear more than once in the actual license plate. Here you'll see that since we have 3 letters to choose and 3 numbers to choose, so 3 digits to choose, that we really have 6 spaces. So often it's helpful, draw those 6 spaces out. Those are the choices we must make. Now for each of these, I need to consider the number of options for this counting problem. Since there are 26 letters available for the first, then I would have 26 possible letters for the first times 25 for the second and 25 for the third. The number reduces there because we cannot have repetition. For the digits, before, when we could have repetition, we had 10 times 10 times 10. Now we have 10 times 9 times 8, so that we do not have 3 threes in a row. You'll notice that this 26 times 25 times 24 can be written as a permutation. This is truly 26 permute 3. So out of the 26 letters, we are choosing exactly 3 of those. I multiply this by 10 permute 3, representing the 3 digits that cannot repeat. So you can really work this problem as a counting problem or using the product of permutations here. Either way, you should come out with 11,232,000 different possible license plates that are possible here. Now we'll look at selecting arrangements when order matters. Here we have a city council with 7 members. So these are people, so obviously no repetition. We must select from those 7 members a 4-person committee. Now here we have a committee where the order matters because I care if I am a member and I am mayor or secretary. I have a different job. So mayor, deputy mayor, secretary, and treasurer. Those are the 4 positions. These are like key points to tell you that order matters here. That's how to recognize that from a prompt. Here the question is, how many executive committees are possible? Now again, you can think of this as a counting problem. There are 4 people that we need to choose. There are 7 people to choose from for the first, for mayor position, the deputy mayor, then we'd have 6 people to choose from, secretary 5, and treasurer 4. So you can do this problem as a counting problem, 7 times 6 times 5 times 4. We multiply the number of choices for each of the options we must make. You'll notice though that this product, since it goes from 7 to 4, this is a permutation. This is 7 permute 4. And so in your calculator, you can do this either one of those ways, and you should get that there are 840 different arrangements for this committee. Now, when we do not care about order, so we wouldn't have a deputy mayor, a secretary, we just care about the people they're chosen, or we just care about a group of people. So here we're going to find probability of guessing the top 5 winners. We don't care about order. They don't get first, second, third. They're simply just the top 5 winners from a group of 24 finalists in a spelling bee. When I'm given a prompt such as this, there's no indication that order matters. There is also no repetition. You can think here we're dealing with humans, so there is no repetition. You have 24 people, and we are choosing 5 of those 24 people. So this is a grouping. We are selecting 5 of the 24 people. In a prompt such as that, this tells us that we are dealing with a combination. So because there are 24 finalists, we want to choose 5. You can think of choose as when you have that C here for combinations. This would be 24 choose 5. So the combinations here in would be 24 and 5 for your selection for R. Using a calculator or using the equation, here I've written this out using the equation, and this is simplified. So in the top you had 24 factorial, in the bottom you had 24 minus 5, which is 9 19 factorial. So you'll notice 19 factorial canceled in the top and the bottom. And then I have r factorial that remains here, 5 times 4 times 3 times 2. If you can cancel common terms, do so, because that will help you for your calculation, but you can just type all of this in, or you can use the combination feature on your calculator. The solution here should be 42,504. So that would be the number of ways there are to group or to choose 5 people from 24 finalists. And lastly, we were asked to actually find the probability here. And I highlighted that. Make sure that your very last step, you need to find the combinations before solving that probability. Since there is only one way to choose that one particular selection, then this probability would simply be 1 out of that number that we have for the combination. So 1 divided by 42,504. Your computer for MyLab Math is going to ask you to simplify those. So that was one of the reasons I was mentioning. If you have a complicated answer, be sure to simplify that before entering it. But usually they'll give you a little warning there before your last submission. So this would be how to find that probability. Here we're going to look at the ice cream shop that offers 24 different flavors of ice cream and 7 different toppings. We're going to look at a few different problems here. So each of these are worded differently. How many different sundaes can you create using 1 of the ice cream flavors and 1 of the toppings? So keep in mind there are 24 flavors and 7 different toppings. Since I need to make the 2 choices, I'm going to multiply, just counting problem, multiply the number of options I have for each of those choices. So 24 times 7. And that would be how to solve this problem. We're going to look at a couple different problems here and see how the math changes. So for the second case, how many different triple cones can you create from the 24 flavors if the same flavor may be used more than once? So we don't have anything about toppings here. I have 3 decisions. I need to decide what goes on each of those layers for my cone. And I can't have repetition. I can have vanilla, vanilla, vanilla if I choose. So this would be 24 times 24 times 24. This is telling me I do have repetition allowed here. A flavor may be used more than once. Now, if we specify which flavor goes on the bottom, middle, and top here, so how many different triple cones can you create with 3 different flavors? Then this reduces the values for each of my choices here. So I have 24 options for one of those layers, the bottom layer, but then I only have 23 for the second layer and only 22 for the third. You can work this as a counting problem, so this would simply be the product of each of those, or because this is the equivalent to 24 permute 3, you can work this as a permutation problem. Using the 24 flavors, how many different triple cones can you create with 3 different flavors if you don't care about the order of the flavors? In this case, if we have vanilla, chocolate, and strawberry, it doesn't matter if one was on the bottom or the top. As long as you have those 3 flavors, you're still happy you're getting to eat all 3 of those flavors by the end of the day, if you can eat it before it melts. So in this case, we should have fewer than we did in that last problem. So this would be a combination. So really it's that answer that we had before divided by 3 factorial. 3 factorial because the 3 different levels of the cone, you could swap those around. So if you take a moment and if you were to sketch out some examples of cones here, there would be 6 different types that we're now condensing to 1 because we only care about the groupings. So this is a combination, and this is 24 choose 3. So in your calculator, you can use this feature. It's going to be fewer than what we had before. You'll see that the 24 here divided by 6 will reduce that to 4. So you'll have 6, a factor of 6 less than you would have before. So it'll be the number that we had in the previous case divided by 6. You may see some problems about probability, which are also using lottery balls. And so in this problem, the first part of the problem, it says something like compute the number of ways in which R lottery balls can be selected from a pool of N balls. So I might have 52 that I might choose from, and then I want to select 5 for my R. So N is your bigger number here, and R is the number you're selecting. this is an example of a combination, because in these lottery, if we don't care about order, here we just care about that selection as a group, then this would be a combination. Whatever you are given as the total number would be your n, and then you're going to use combination feature in your calculator or the formal equation, and used r as the number you're selecting. So in these problems, if you're asked to find probability of winning such a lottery, then that would simply be the one situation divided by all of those possible outcomes. And so 1 divided by the number that you had previously. Okay, so in summary, these were a few examples you may encounter in your homework when dealing with arrangements. When selecting the formula or the approach, you want to consider whether repetition is allowed or not. And then following that, when you know that you can't have repetition, then you need to consider order. If order does matter, then you're using a permutation. And if order does not matter, you'll need to divide by another number to get those combinations. If the problem is actually asking for probability, remember to break that up. So if you were to come up with an outline for your math problem, that will be the very last step. So in those probability problems, remember that lastly, you want to find the probability as the final step, and don't enter your number of combinations, so be careful. All right, good luck on that homework.